Thanks for joining me for this third part in this series about writing real-time database triggers with Cloud Functions for Firebase. My name is Doug, and what I'm about to tell you here follows from the first two videos, so be sure to go back and watch those first if you haven't already. In those first two videos, you saw how I built, using Cloud Functions, a couple triggers that automatically replaced the word pizza with a pizza emoji in a chat room. Why? Because it adds pizzazz. Those triggers respond to newly added messages and also messages that were updated after they were initially added. But what do you do if you want to respond to messages that were deleted? Well, I'm sure it's no surprise that you'll do it with an onDelete trigger. And here's how I want to use it. But it doesn't really involve pizza this time. What I'd like is for my chat rooms to have a message count to be queried easily. Why do I need a message count? Well, I'd like for client apps to be able to know how many messages are in a room without having to query, download, and count all the message children in that room. That's too much to do when you just want to count. So, I'm going to do two things. First, I'll change my existing onCreate trigger to read, increment, and write the message count when a new message is added to a room. Second, I'll add a new onDelete trigger to read, decrement, and write the message count when a message is deleted for whatever reason. I'll store this count in a new child value in the node for the room at the same level as the messages node. This is the value I'll increment and decrement as messages are added and removed. Okay, let's go to the code. Actually, no. I need to think about this first and make a plan before I start writing code. There's one important thing you need to keep in mind when writing Cloud Functions code. It turns out that each invocation of your functions may be running at the same time. They don't just run one after another in sequence. That strategy doesn't scale well at all. Instead, the Cloud Functions runtime needs to be able to run your functions in parallel under load. Imagine that you have many people chatting in a room, with each of them adding and deleting messages, and they all need to update the message count for that room. The problem here is like this. Each invocation of onCreate and onDelete needs to read the existing message count for the room from the database, make a change to it in memory, then write it back to the same place. But you could easily have a situation where two function invocations, let's say an onCreate and an onDelete, are running at the same time, and they both initially read the same message count from the database, make their changes to it in local memory, whatever that might be, but one of the values incorrectly overwrites the other, and we don't even know which one it will be. With this situation, in this diagram, where the message count is originally 4 and two functions try to make a change to it, will the new message count be 3 or 5? Well, I'd like it to go back to 4 after both an increment and a decrement, but here, the final result will obviously be wrong, no matter the order in which the write's complete. This situation is called a race condition, and that's the problem I'll have here if I don't do something to correct it. The good news is that it's easy to solve with a database transaction. So, let's see how that works in code. First, notice how this onCreate function returns the promise from the call to update. This isn't going to work anymore since I have to do the transaction after the update completes. The easy thing to do here is use async await. First, I'll make this handler function async by using that keyword where its definition starts. Then I'll use the await keyword instead of return to pause the code until the update completes. After that, I need to build a reference to the location of the counter in the database. I can use the snapshot ref as a start, which points to the location of the node that was created. Then I'll work my way 2 nodes up the tree using the parent property of the reference. Now I have a reference that points to the node of the room at rooms room ID. I need the message count child under this location, so I'll use the child method to build another reference to that. The value referenced by countRef is what I want to read, increment, and write. I'll use the transaction method on this reference to perform the transaction. It requires a transaction update function, and that function receives the value of the database at the location of the reference. Here, I'm expecting the message count value at that location, and I'll simply increment it and return it to tell the transaction the new value to write back. Now, I'll write the onDelete trigger. It's just like onCreate, so I'll copy and paste it, but of course I have to change the name. I'll also copy the transaction from onCreate. It'll be exactly the same, except I'll decrement the counter this time, and I still need to return that promise from the transaction. That should do it. Now, my onCreate and onDelete are working in tandem to manage the message count of each room. The transactions they're using are said to be atomic, meaning they complete without the possibility of interruption, which means we no longer have a race condition. If your code doesn't have the possibility of a race condition, then don't use a transaction at all. It'll just slow things down unnecessarily. So be sure to think through your situation carefully. If you want to learn more about real-time database transactions, be sure to read the documentation. The link is in the description below. But right now, I want to test this code to see how it works. If you remember from the first video in this series, I have a script that simulates adding a series of messages to a chat room. I'll run that, then watch the results in the Firebase console. Okay, I'll run the script at the command line and see that it simulates the messages. At the same time, in the console, you can see the messages appear, and you can also see the message count going up with each new message. Then, if I delete all the messages here in the console, you can see the counter drop back down to 0. That's pretty fun to watch, don't you think? Alright, the code is done, but there's one more thing to know about onDelete. You probably noticed its handler function gets passed a snapshot object as the first parameter. That snapshot contains the old data that was just deleted from the location of the trigger. But if you don't use that object at all, or the context, you can just leave them out of the handler function definition just to keep things clean. Okay, using onCreate, onUpdate, and onDelete triggers in Cloud Functions, you can do all sorts of useful work in response to changes in your database. And there's also an onWrite trigger which you can use that gets fired for all the changes that would also cause onCreate, onDelete, or onUpdate to fire. But you have to dig into its snapshot changes to figure out exactly what happened. So I just use the other 3 triggers because they're easier. In all cases, your code is secure from hacking and you can update its logic at any time without having to build and publish your app again. Cloud functions are powerful, but after working with them, you may feel it's slow to write, deploy, and test your function repeatedly. You can speed up that cycle using the Cloud Functions emulator, and I'll show you how to do that for database triggers next time. So be sure to tune in right here to the Firebase channel on YouTube to watch that video when it's ready, and I'll see you then.